In the next exercises, we will use a library called Rasa NLU, or Natural Language Understanding. I'm one of the creators and maintainers of this library. Rasa NLU provides a high-level API for intent recognition and entity extraction, and it has a number of useful components already built in, which can help you build chatbots. To use Rasa, we provide training data in a JSON file. JSON is a popular human-readable data format based on key-value pairs. We import the load data function and call it, passing the path to the training data file as an argument to create a training data object. This object contains a list of dictionaries called training examples. Each of these dictionaries contains an example message, its intent, and a list of entities found in the message. We can convert one of these dictionaries to readable JSON using the json.dumps function. Indent equals 2 specifies the number of spaces to indent. The way to use Rasa NLU in Python code is through an interpreter object. This contains your trained model for intents and entities. To use it, pass a message to the interpreter's parse function. This returns a dictionary with the extracted intent and entities. Now let's see how we can create an interpreter. To train our model, we create a configuration and a trainer. First, we import the Rasa NLU config and trainer objects from Rasa NLU. We create a config object by calling Rasa NLU config with a dictionary of parameters as the command line args argument. This dictionary contains a pipeline key, which we'll explain in the next slide. To create the trainer, we call trainer with the config as its sole argument. We then call trainer.train, passing in the training data as an argument. When the model is trained, this returns an interpreter object. In the previous slide, we used the spaCy sklearn pipeline. A Rasa pipeline is a list of components that will be used to process text. The NLP spaCy component initializes the spaCy English model. Then the NER CRF component uses a conditional random field model to extract entities. You'll learn more about that in the next slide. The NER synonyms component maps entities with the same meaning to the same key. For example, if we want to treat NYC and New York City as synonyms. The intent featureizer spaCy component creates vector representations of sentences, exactly as you did in earlier exercises by using spaCy's word vectors. And the intent classifier spaCy component is a scikit-learn support vector classifier. When the model is trained and used with this pipeline, these steps are performed automatically. When creating a Rasa config object, you can either specify the name of a predefined pipeline or pass a list of components you want to use. In order to train a custom entity recognizer for your domain, the recommended component is NER CRF. This uses conditional random fields. Conditional random fields are a machine learning model. We won't go into the details of it, but it works well for entity recognition even when you have quite a small training dataset. One downside of relying on word vectors is that if important words are misspelled, it can be very hard for the classifier to correctly predict intents. And for many words, there simply aren't any word vectors because they didn't appear in the training corpus. Rasa NLU can remedy this if you include the intent featureizer ngrams component. This component looks at all the words in your training data for which there aren't word vectors, including misspelled words. And then it looks for sub-word units, or character ngrams, which are predictive of the intent. For example, if the word dollars is an important indicator of a price request, this component will pick up the sequence of DOLLA as an important one. You do, of course, have to make sure that your training data contains these out-of-vocabulary words and misspellings, or else the model won't be able to learn from them. Now it's your turn to apply what you've just learned.